Welcome to this video presentation. Today we will be looking at how to make use of our Cisco Packet Tracer in order to establish a local area network. That means we will be using our Cisco Packet Tracer termination software in order to establish, we'll be making use of this software to establish a local area network. So first thing first, we are going to open our Cisco Packet Tracer termination software, and here is our Cisco Packet Tracer termination software. We double click on it and wait for this program to open. Alright, our Cisco Packet Tracer termination software is now open. Now we are about establishing a network, and in order for us to establish a network, we need some network components. And some of these network components will enable us to create this network, the local area network. Now we have network components like our end devices. We have network components like our intermediary devices, and we have network components like our network media. As we all know, our end devices are devices that serves as the sources or destination of a message transmitted over the network. These end devices are those devices that serves as the sources or the destination of our message being transmitted over the network. And we are going to make use of the personal computer, the PC, as so many people do call it, or the desktop or the laptop, but we are going to make use of the personal computer as our end device in this situation. Now this is it. We are going to make use of five personal computers to create this local area network. And here we go to get our end device, which is the personal computer. We go to our end devices over here below the Cisco Packet Tracer platform, and then we choose the desktop icon, the end device with a desktop icon, and then we place it at our platform. We have to take in five desktop end devices. 1 2 3 4 5. There we are. We have gotten the five pieces that will be used to create this local area network. But before then, let's arrange our five pieces in a good way. Let's arrange it in a way that it will look more matured. Alright, there we are. We have succeeded in arranging our end devices in a well arranged manner. Now the next thing we will need is an intermediary device. And the intermediary device connects end devices to the network. An intermediary device connects end devices to the network, and at this time we are going to use an intermediary device called the switch. And we have to get our switch. How do we get our switch? We have to come below the Cisco Packet Tracer platform, and we go to network devices, and below the network devices we select on switches, and various switches will appear, but we have to choose one of the switches, and the one we are going to use there is the switch with the label 2960. So we click on it and then bring it to the platform. All right, we have achieved that. We have achieved bringing out our end devices, our 5 end devices, and we have also achieved bringing out our intermediary device, which is the switch. Now, as I said before I started, that in order to create a network, we need network components, and I mentioned 3 network components when I started. I mentioned the end devices, the intermediary devices, and also the network media. And we have succeeded in bringing out the end devices, we have succeeded in bringing out the intermediary device, and now we are to bring the network media. We have to bring the network media. The network media serves as the medium. It serves as a medium where communication is being sent across the end devices and the intermediary, between the end devices and the intermediary. So that is to say that the network media enables communication between the end devices and the intermediary device. The end devices in this case are personal computers, and intermediary device in this case our switch. And we have so many end devices. We have so many network media, and let's bring out our network medias. We come below this place where it is labeled connections that have the lightning icon. When we click on it, we can see so many network devices, but the network devices we are going to make use of is the one called the copper straight through, the copper straight through network media, the copper straight through network media. The reason being that the copper straight through network media enables us to connect devices that are not the same. In this case, we are connecting devices between our end devices, which is the personal computer, and our intermediary device, which is the switch. So therefore, we are going to make use of the copper straight through network media. All right, that being stated, we click on our copper straight through network media, and we are going to connect each personal computers to the switch. We will be connecting each personal computers to the switch, and this can be done. And this can be done by clicking on the straight through connection media, which has been done, and going to each of the PCs and connecting them to the switch. Now we come to PC0. We are going to use the fast internet interface of personal computer 0, and there we make a connection with the switch and also the fast internet of the switch. And also we come to PC1. We click on our copper straight through. We connect using the fast internet 0 of the PC1, and we'll connect to the switch using the fast internet 0/2. We make sure that they are well coordinated. All right, we do the same to all other PCs we are meant to use for our network. And remember that the ports that is being used for each of the PCs is their fast internet 0 port. PC2 fast internet 0 port is what is used, and each of the PCs are being connected to each of the fast internet ports of the switch. So there we go. Alright, we have succeeded in connecting our PCs to our switch using our connection media, which is the copper straight through connection media. Now, if you look at what we have done so far, you will notice that during the course of the connections, there were some lights, there were some colors that appeared at the end of each connection media, at the end of each copper straight through connection media. Now, if you notice that our the colors of those light of those the colors now are green, the colors now are green, and this color have meaning to our connection. When the color turns green, it means that our connection is ready. At this point, our connection is ready for any configuration, for any transaction, for use. But when the color turns red, it means that there is an error somewhere. Our connection is not yet ready. That means our connection had undergone a mistake somewhere and it needs to be corrected. But when the color turns orange, it means that our connection is trying to determine its state, if it is ready or if it is not, if it is faulty, having some fault in the connection area. But at this point, as we can see, the color at the end of our network media is green, are all green. That is to say that we are good to go, and that is to say that our devices are ready for configuration and other things that will be implemented on it. Now that being done, the next thing we are going to do is configuring each of our personal computer. Now we have to configure each of these PCs, and we do that by giving an IP address to each of the PCs, and we do that by following these steps. We click on the PC, we go to desktop, IP address, and then we key in the IP address we wish to use: 172.31.32.2. And then below it is our subnet mask text box. Clicking on the subnet mask text box will automatically give us the subnet mask of our IP address. Look at this, and this is our subnet mask address for our IP address. And on getting our subnet mask, we close the window. Alright, we have done that for PC 0, so we'll do that for PC 1, PC 4, PC 3, PC 2, and there we go. All right, we have succeeded in giving each of our PCs an IP address, and we have gotten the corresponding subnet mask. Now our connection is ready. It's ready, but before then we have to test this our connection. Whenever a network is being established, we do what we call the echo request. This echo request is sent from a sending device to receiving devices, to make sure that to enable us know if actually our connection is okay. So now we are going to send an echo request from our sending device. We are going to choose a sending device from any of our PCs, and I would like to use PC0 as our sending device, and our PC0 have an IP address. We have to know what our IP address for PC0 is. Our IP address for PC0 is 172.31.32.172.31.32.2, and yes, that is it. We have to copy Ctrl+C our IP address for our sending device, which is PC0, and then we close. All right, now the next thing to do in order to send this echo request is to we go back again to our sending device, which has been chosen. In this case we have chosen PC0 to be our sending device, and then we click on command prompt. On the command prompt, and then something like this displays. A command prompt is displayed in this manner. Now the process whereby we send this echo request is known as pinging. The process whereby we send this echo request is known as pinging, and we are going to type some command prompt instruction in order to send this echo request. And this is how we do it. We type in ping spacebar, and we are going to, and in this case we have an end device with this address. Then we have after typing in the IP address of one of the end devices, we hit our enter key. Oh no, we are told that we have an invalid command. That means we might have made a mistake in the way in which we typed in our command in the command. All right, there we go again. Repeat our step. Ping spacebar, then the address of any of the IP address of the end device, and then we press enter. All right, now it's going. Now look at it. We have indeed achieved what we want to achieve. Now looking at what we are seeing in our command prompt, we can see something here. Now look at this. Ping statistics for end device with IP address 172.31.32.10. That means this PC, this end device with this IP address, the information concerning it. Now look at it. It has been able to send four packets. This is it. Send 4 packets, and it has been able to receive 4 packets and has lost 0. That is to say that any packet that will be sent from our sending device will go to 4 devices. and these four devices will receive it. That's why we have the received 4 here. And not only receiving it, there will be no loss at all. That means our connection is what? Okay. Since if our sending device sends a packet, sends a data, sends an information, it will be received by 4 pieces, and also there will be no loss of information. Now also we notice here that our minimum time for this to occur was 0 milliseconds, and the maximum time for it to occur is 29 milliseconds, and also the average time for it to occur is 15 milliseconds. Now that is to tell us that our connection is okay. All right, now we close our command prompt. Now the next thing we are going to do is this. We are going to use stimulation in order to see how these messages will be displayed, will be dispatched across the network, using this our stimulation in order to checkmate if indeed our informations can be transferred within the network, and if each pieces can receive information sent from the sending device, and to see if there will be any loss of information. Now we can achieve that by using our stimulation platform. And there we go. We use our simple PDU. We have to add a simple PDU to our receiving device, and as we all know, we have chosen PC0 to be our receiving device. So we get our simple PDU, and then we come to PC0 and we attach. And this simple PDU have an icon of a closed envelope. This closed envelope signifies a packet. That means a message and information that is being sent across network. So we have attached it to our PC0, which is our sending device. So what next? We are going to activate our stimulation platform. And how do we do that? We have to go to our stimulation platform over this place and click. The stimulation panel is now open, and it being open, we have to click on the auto capture /play button. The auto capture /play button. This will now show us, and this will now show and implement our connections. It will implement our connections and give us what our connections results to. Now clicking on it, we see something like this. Close it. Clicking on it, we see something like this. Now if you watch very well, you can see that our messages, our packet has the capability of transferring, has the capability of sending information to the various end devices. As you can see, it sends to PC0, it sends to PC1, it sends to PC4, it sends to PC2, and it also sends to PC3. That means there can be transfer of information within this end devices through the help of the switch. Now this happening, we have concluded that our network is okay, since our network, when bring to the real sense, has the capability of transferring information, transferring packets successfully without any loss. That is to say that our connection, our local area connection, has been achieved. Now we are going to do one more thing before we finish this session. We will have to design our interface in a way it will look nice. And how do we do that? We do that by adding some design tips. We come over this place and we take our draw a rectangle and we fill color. We want to give each each device a background, a color background. This is okay. Okay. And lastly, all right, and lastly, we are going to make a colored background for our switch. I'll be using the eclipse shape. I'll fill the color and I will use the yellow color. Okay. All right. Now, this being achieved, we have successfully created our local area network. And I really want to thank you for listening and for watching this, and I hope this has been of good help for you in your knowledge of creating a network, a network, and in this case a local area network. I hope you really gained from this lesson. I'll have no other thing than to say bye for now until the next edition of this video comes up. Bye.